Okay, so more on timber frame construction. With this drawing we're going to look at the timber frame eaves detail of a roof along with the head of a window down here. Alright, so just like the previous video, a few points on the comparison between this timber frame detail and that of a solid concrete wall detail. We know the main difference in this is the internal leaf. The timber frame panel, which as we know is made up of your 5 layers, your plasterboard, your vapor control layer, tightness layer, your timber studs with insulation, your OSB and your breather membrane. Alright, the external leaf is as usual a concrete block, or sometimes could be some sort of a brick outer leaf. We have a triple glazed head of a window, and then we have the roof area here. Now another difference I suppose here is the lintel. With our solid concrete wall, a lintel, as we know, there's 2 concrete lintels like this, but with the timber frame panel, they don't put concrete lintels into place. They put 3 pieces of wood, or depending on the size of the panel, lengths of wood going across the piece there. So there's 3 pieces of wood, 225 by 50, 3 of them fixed together, and that's your lintel there. That's going to carry the weight, and that's the bottom of the panel, those pieces of wood there. There's a double head piece as well on the top of this, so the wall plate and the head piece, the top rail of the panel, just extra support for that. We have slates on the roof, which is normal, but one other thing that's different here is with timber frame construction. Always with timber frame construction they use a trussed style of roof. So you'll remember from our roofing theory, a trussed roof is a roof that is made, when the trusses are made in a factory, they're delivered to site and they're lifted into place. The truss rests then on top of the wall plate here. Alright, if I was to look at the eaves detail of a concrete wall with a traditional cut roof, you may remember the wall plate is up there and there's a bird's mouth joint whereby this piece of wood, this rafter, it cuts into the wall plate. Right, the bird's mouth joint is there. There's no bird's mouth with a truss roof. You don't need to cut the trusses into it. You just rest the trusses on top of the wall plate and then they're nailed down to that wood there. Alright, so we'll make a start on that. I'll take that away. As usual, we'll have a well presented page, so our border, our title box, your name, your heading, timber frame eaves detail and window head, and a scale of 1:10. Equipment we're using, we've got a T-square, we've got a 60-30 set square, 45 degree set square, we've got a 2H pencil, we've got a H pencil for your dark work. As usual I'm going to use a HB just so it's more clear on the video, rubber, and your pens, red, black, green and blue pens. Okay, and as always we'll start in the place whereby usually you would be working on building it. So we're going to start with the timber frame panel and we're going to start fairly central on the page. I must emphasize, as always, everything I do early on especially is light work, but I'll be doing it slightly heavier just so it's clear on the video. I'm going to zoom into the center of the page there a little bit. I'm going to pick a position and I'm going to draw a light line. Again, it's a light line, random distance down the middle. I'm going to measure 150 millimeters for my panel, timber frame panel that I'm drawing, and I'm going to draw another light line. Okay, I'm going to pick a position randomly on the top of that and make that the top of my timber frame panel. I'm just going to rub out those top bits again. As I always say, everything so far is being done lightly. I might extend this just a little bit further down. How far down can vary. Don't overthink it. Pick your position, and let's say that's going to be the bottom of our panel. So this is going to be where the roof is. This is going to be where the window is. Now, the panel itself, as we said, on top of the panel there's 2 head pieces. So there's like a wall plate, which is fixed to the top of the panel, 50 millimeters down. And then there's the actual top rail of the panel itself. So in actual fact, this piece of wood is the top rail of the panel. And then when that's fixed into place, the carpentry team will have to fix down another piece of wood on top of that, known as the wall plate. And the wall plate is going to give double support, and that is where you're going to fix your trusses to. Now the window's going to be down here, so we're going to do our lintels. There's going to be 3 50mm pieces of wood. They're going to be our lintels. As we can see now, lintels can come in different types of material. 225mm is the standard height for this piece of wood. That can vary, by the way. Sometimes it's just 200, but in around that area of size. And once again, we are looking at the ends of pieces of wood there. And there. Alright. We then, on the bottom of that panel, again above that for extra support, there's another 2 pieces of wood. So this just takes a bit of learning, a bit of practice. There are 2 more pieces of wood going above that lintel for even more support on that. And we see photographs of that kind of work there. So the timber frame panel over the window and underneath the roof, there's a lot of extra support. It's just a matter of getting used to doing that. 2 head pieces basically, 2 sole pieces, and then your lintel there. On the external part of our panel, as always, we have a 12mm piece of plasterboard, a sheet of plasterboard. We'll draw that into place. There. On the outside of the timber frame panel, we have our 18mm OSB wood. So we'll just extend that there. And then inside the panel, in between all those timber studs, we have our wool insulation. Just to finish off the panel itself, we'll get our pen work, red pen. Inside the plasterboard, we have our vapor control or air tightness layer. And as we know, that will stop any moisture coming from inside the house passing through into that stud. We do not want any moisture getting in there, or else it may cause the timber to rot. On the outside of the OSB wood, we use a blue pen to mark the breather membrane, and that breather membrane will allow any timber in here, any moisture that's already in the wood that evaporates out through condensation or warm weather, it can escape out through the breather membrane, but it cannot get back in. Okay, now at this point now I'm not going to even draw the outer leaf yet. The outer leaf is built a little bit lower down, so you know that the carpentry team will build up the timber frame panels, then they'll do the roof, and then the block layer comes in. You can see there the blocks have gone, or they're a bit lower than the actual panels themselves, depending on the angle of the roof. So the block layer will come along and just build up the blocks as far as the roof. So at this point we're going to put in the roof into place. Again, I must emphasize, it's a trussed roof, so we are working with trusses, and the truss just rests on top of the panel in this case. With the traditional cut roof, the rafter is cut and it's a bird's mouth joint. It cuts into the wall plate there. So in this case it's just resting. So I'm going to just draw a line across there lightly and randomly in distance to kind of mark the position of the bottom part of the truss. The size of the timber generally in a truss is 150mm, so I'm going to measure up 15mm there. So a little bit. I'm going to draw a line across there again lightly to mark the bottom part of that. Now, the angle of the roof can vary depending on the architect design. For the sake of this drawing, we're going to just go with a 30-degree angle, and that's going to just rest up along there. This is all light work, by the way. How far down here I haven't decided yet, but it's just going to rest over that there. I will now rub out these lines here just to avoid any confusion. I'll probably do them not too far anyway. And I will then measure 150mm out that way, 15mm, and I'll draw another line parallel there. Okay, I'm extending these on down a nice bit. Haven't decided how far down yet, we'll decide that shortly. That is the position of the truss itself. So you can see there, that's pretty much what we have in place. Alright, I'm not going to worry about drawing this bit for this drawing, it's this area that I'm more focused on. These nail plates that are used between all of the joints, we'll draw a nail plate in. I'm not even going to worry about the size of the nail plate, I'm going to just draw in a rectangular shape that covers over this joint here. Draw that into position. There. I'll shade that in as well. So that's the nail plate holding that together. Now, this point before I start marking off fascia and soffit, I'm going to actually draw the external leaf there now, so I'll get a better idea. So we've got a 50mm cavity on our timber frame walls. I'm going to lightly extend that up, and we've got a 100mm external leaf, so I'm going to measure across there 100mm. Let me scale it down as 10, and I'm going to draw that up there. So extend it up pretty close to the truss, and that's where the top of the block work is going to go. I'll just extend that down. I'll just close that off there, we'll tidy that up. And what I'll do is I will draw my lintel into place here. So we have an 80mm concrete lintel here, a normal lintel that we're used to. And I'll start drawing blocks all the way up. I'm probably going to end up with a smaller block on the top. That will be up for the block layer to figure out, use a smaller block or else cut the top or whatever they have to do. So a smaller block may potentially used on the top along there. Okay, and with concrete lintel there. Now we will begin to work on the softened fascia. So again, how far out the softened fascia come can vary. Don't come out too far, but maybe pick a position round about there and go vertically up, and then route that line there. And we have got a 25mm fascia. With the battens and all are going to decide the height of the fascia. We're going to get to that in a moment. I'll just finish up the bottom of the fascia there. First of all, it's going to extend down a little bit lower. And we've got a 12mm soffit going across there. Now, we are now at the point in the area where we've worked before. It's good practice, I suppose, to do it again. We've got to draw in battens, we've got to draw in slates and so on. So we'll do 2 or 3 courses of slates. It's good practice to work on this. And as we remember from our roofing drawings, that we should be in a good place to be able to work this out. Alright, so in a position about 50mm out from the roof. Alright, so I'm going to set 0 there. I might just zoom in a bit further on that there now. So I just extended that down, and I'm going to extend out 50mm, because the slates have to go out 50mm. I'm going to measure a position 250mm, and I'm going to extend on. That will give me the center of my first batten. So I'm going to go 2.5mm to the left and 2.5mm to the right for that batten there. I was going to go perpendicular to my 30 degrees, so you can see where my set square is. It's a 50mm by 25mm batten, and that is the first batten drawn into place. Now, go back to that point there, 50mm outside of it, and I went 250 to get to the center of that. I then go 350, and I'm going to go 2.5mm to the left and 2.5mm to the right. The top of that batten I'm going to lightly extend up, just to give me a guideline for the top of that. and I'll draw maybe 1 or 2 more patterns. From there, it's just 250, 250, 250. So for example, I set 0 here, and I go 250, but then extend on my 50 millimeters and draw the batten in. And then go 250, extend on your 50. Okay, so we've done this on a worksheet before. If you still struggle with this, it's worth going back to that worksheet and practicing that over a couple more times. So 250 and then 50 there. Alright, we are looking at the ends of piece of wood here. So we will join the diagonals. Let's rub out that guideline there now. Battens are all in place. I can now help, this will help me get the top of my fascia. I'll just extend that on, and where that top of that batten hits the outside of the fascia, that will give me the top of my fascia. So we can rub out all of that as well. The only way to get good at that, guys, is practice, constant practice on slates. Tilting fillet then, just in behind that fascia to stop any water gathering in behind there. Random angle on that, your piece of wood there. And those battens extend on up throughout the roof. Right, so our first slate is 250, so from the centre of that there, 250. I use 250 millimeters, so 25. Okay, so it extends out to there. The next one, 350, so from the centre of that, as we always say, at best a thick line. Try and make it so that there's a gap clear to be seen between those, so it's not just a big untidy smudge. And then our first slate of 600 can begin along there, and from there each slate is 600 millimeters from the centre of the batten. And we'll do one more here, down along like that. Okay, so that's that area done. We then need to put in the felt, so we'll use blue pen once again. The roofing felt runs down along underneath those battens, up along the tilting fillet, just a little bit down over the edge there. We'll draw a gutter into place. We're not going to overthink the size of the gutter too much. We know gutters can vary in shape and size. We'll do a gutter there around 100 millimeters by 100 millimeters square. Might put a little angle on the corners of it just to give it a bit of an aesthetic look. That's the water in place there. Okay, at that point there, we're almost finished roof. A few more little bits to do. We have a vent that goes into the soffit, so I'll just draw a line there. We'll make our vent, let's say 80 millimeters. Okay, that's our vent. We need air to be able to get up through up here into the roof. We don't want to be blocked off by insulation, which we're about to draw. So we'll draw our Eaves ventilator into place here. So basically a rectangular piece. We've looked at photographs of these ventilators, 30 millimeters, so 3 mil that way, and extending on 700 millimeters that way. So there's our Eaves ventilator. That will stop any wool insulation blocking that off. We will then Add in some mineral wool insulation that goes in between the joists. We'll take our time with this, be nice and tidy with it. As you can see there now, the Eaves ventilator will stop that from blocking or getting stuffed up there. Air can pass through that. And often nowadays there's 2 layers of that mineral wool insulation in a very highly insulated house, so I'll just lightly guide the lines there. Down in like that, a well insulated house. That is pretty much all of the roofing area done. We are now going to go down and look at doing the window. There's actually maybe a cavity closer needs to go across there, so you're talking, let's say, a 15mm cavity closer in there. That'll be an insulated cavity closer, so we'll just show a bit of insulation of that. And there will be a cavity closer across here as well. Now at this point we can start to draw in the window detailing. Alright, so we will zoom, bring down here. So I'll just draw my cavity closer just there. Now, as I said, at this point we can start to draw in the window detailing for it. So as usual, we're getting used to, we're just going to do a simple fixed frame window, and bring that over here. There. So windows can vary in size. We're going to make sure it's thermally broken and triple glazed. A standard size I like to work off is 100mm by 80. But as we said, that can vary in size. There is room for variation in that. So I'm going to pick a point there. Where it starts can vary too, but it's always good to sort of start on the edge of the cavity. 100mm. Very important to do all of this lightly. By 80, so I'm measuring down 8mm there. Okay, so there's my rectangular shape for the window. I'm going to put a little 45-degree angle on the corners of that for an aesthetic look. I'm not even going to think of the size, I'm going to just estimate that. Have those fairly similar. I will then, from the corners of that, go down 5mm to allow the glazing, the triple glazing unit to slot into position there. Rub that out. Right, so at this point I'm happy with the shape of it, so I can actually go over it a little bit heavier maybe. As we said, we want this to be thermally broken, a window frame. So we're going to put some insulation inside the frame there to stop any thermal bridges. Forming. Alright, and then we'll start with the glazing. So I'll just draw the outside part first. I'll extend down around that bar. And we'll extend down around that far. We'll make those panes of glass about 1mm thick. There and there. I'll draw the two outside panes of glass. And then to get that middle one, you're best off just estimating your millimetre in the centre of that. And we have our triple glazing unit in place there. There is a little bit of DPC work, right? So the DPC above the window, what happens is they have their battens there. It will literally just, DPC is going to come around the front of that, up the front of that batten, across there, and up just the front. It's stapled or wrapped in underneath the breather membrane there. Your DPC comes down along there to stop any moisture or any driving rain getting up into that position. It's important to get that right. I might just add a layer of plaster our render to the front just to tidy up all the block work. 18mm render, and that will go around the front there, and then your 12mm plaster will go underneath there as well. At that point pretty much everything is drawn in. It's just a matter of getting your correct labelling done right, so we will start with that. As always we say, with our label work, be neat and tidy with everything that we do. We space up here, here and here, so let's try and pick different parts right. Maybe the internal leaf and the wall will label up here, a lot of the roof components can go up here, and maybe the window components can come down here. Nice and tidy with all that work. So we'll start with that. So I'm going to bring out a line for the wall plate. We're going to bring out a line for the top rail. We'll bring one out for the plasterboard. The vapor control there, the wool insulation and timber studs, the OSB and the breather membrane. We'll go with that for the moment. Okay, so 150 by 50mm wall plate, 150 by 50mm top rail, so that's the top rail of the panel. We've got 12mm plasterboard, we've got the vapor control, air tightness, there. We've got the timber studs, 150 timber studs, and insulation. We've got the 18mm OSB wood, or sheeting, we'll say OSB sheeting, I suppose is better. OSB. And we've got a breather membrane. Okay, so all of those are labelled. We will just label our lintels. I feel they're important to get in as well. 225 by 50mm lintel, and there's 3 of them, so that and that are 225 by 50mm each. I'll just go down here with the window, triple glazing. We'll get the 100 by 80mm thermally broken, window frame. Okay, we will get our concrete lintel over on this side, so our normal lintel that we're used to, 100 by 80mm concrete lintel. We will do the 100mm external block, 100mm external block. We will include a 25mm fascia, I'll put the soffit down here, 12mm soffit. Okay, and we'll just go up and label some of the roof members there as well, to get that finished off. So I'll bring a line out here for the truss rafter, the batten, the slates, and the roofing felt. We'll go with that for a moment. Okay, so this is all a truss, but this is, I suppose, the rafter part of the truss. So 150mm truss, we'll just say, and that kind of covers all of the wooden members of the truss. 50 by 25mm batten, 600mm slate, roofing felt, we'll get the tilting fillet as well, and that should be enough labels on that drawing there. Now you could include your Miller wood insulation or your Eaves ventilator there as well, but there's enough labels in that. So at that point there, now we have that drawing fully complete, fully specified, fully scaled, well presented drawing over the head of a timber frame window, the eaves detail and the trussed roof as well. Okay.